Good afternoon. Welcome, everybody. This is the fourth webinar in the project Flexi-Sync, which is an ERANET SAS project. As mentioned before, this is webinar number 4 in the Smart Energy Systems ERANET project Flexi-Sync. And it's based on, the theme of the entire presentation is business implications from increased flexibility in the district energy grid. Quick facts about this project. 4 countries are involved, 16 partners are involved, and 6 demo sites are involved who are also the need users. And the budget is approximately 4.5 million euros, and it started in August and September 2019, and we hope to finish by the end of 2022. And the service is basically optimized flexibility in the district energy sector. And I am Sujita Selvakumaran. I'm the work package 5 leader, and I represent RISE Research Institutes of Sweden, based in Gothenburg. And I will be talking the first part. I will be presenting the first part, and I'll be talking about business aspects of flexibility. So I will give an overview of what flexibility we have considered and why we have considered it, and basically the findings of the analysis that we have done. Moving on. So we all know what flexibility is generally. It is basically having the room to maneuver, or from a mathematical point of view, it's relaxing constraints to an operational problem. In terms of district energy settings, we presume that it means 3 things. That is the availability of either heat or energy, or going beyond that, basically displacing a peak load or reducing a peak load. So this is what we think flexibility in a district energy grid or district energy sector means. But from a business perspective, we also believe that due to one or all of these mechanisms above, it is also reducing of the cost or price of the district energy service. So we will be tackling the business perspective of flexibility as either flexibility through these 3 mechanisms and also a change or shift in a cost or price. So then the question arises, why do we even want flexibility? And we have thought about it from 2 perspectives. The first one is from the district energy firm's perspective. We think flexibility will lead to a conservation of energy resources and also money, saving money through reduction of peak heating and peak cooling, and also through sector coupling and optimization of combined electricity and heating energy costs will be reduced. But from the perspective of the end user or customer, who may be 2 different entities in this case, there is a perceived conservation of energy resources, and higher and relevant thermal and indoor comfort can result from flexibility, and also it could be a way of saving money. So with these premises clearly established, we could then move on to what we wanted to know from this study. The first thing that we wanted to know was, how has district energy flexibility been captured in existing business models? Or has it been captured? And if it has been captured, how so? And the second question we wanted answered was, what is the connection between existing district energy business models and price models when it comes to flexibility in the district energy grid? Now, before we move on, I think it's important to establish and to explain what we thought about when we thought about price models and business models. Generally, a price model is a core part of a business model, but it is not the end all and be all of it. Business model also talks about or considers the key relationships, the key resources, the communication aspects of the business in addition to the price model. But sometimes especially in traditional engineering-related fields and in the energy sector also, business model is the price model. A lot of firms, a lot of companies think of their price model as the business model. So this is something that we need to be aware of when we are analyzing or when we were selecting literature, scientific literature for this study. So we couldn't be too constrained about dismissing papers only that dealt with price model, because that was also important. So we looked at scientific articles looking at both business models and price models, or either one of them as well. So I move on to the approach. So we did a content analysis of scientific publications dealing with flexibility and or price and business models in district energy. And then we ran a search protocol on both Scopus and Google with multiple combinations of keywords. And the keywords that we selected also were similar keywords which may be used interchangeably in scientific literature, so that we didn't miss any key literature that would deal with any of these subjects. So I would like to first give you some key stats of the search and analysis. We read more than 50 articles. I would say it was more along the line of 70 to 75 articles. Out of that, 38 were relevant to our research questions. And of these, approximately 6 talk about only business models to capture, use, or exploit flexibility in the district energy sector. Another 24 talk only about price models, mostly about either marginal or levelized cost-based pricing models already existing. And some, basically 8, talk about both price models and business models. Now I'm going to present to you the findings a little bit in depth. In terms of price models, as mentioned before, there are 2 dominant price models prevalent in district heating and cooling or district energy sector. The first one is price models set, which are based on the marginal cost of heating. As you know, marginal cost is the cost of producing 1 additional unit of heat. And normally the factors that affect marginal cost pricing are fuel cost, allocation of fuel costs for CHP plants in different ways, and also the temporal resolution of calculation. Now, this is important because normally marginal cost-based pricing assume that the investment costs are sunk costs, and they have a very, very narrow time resolution. I look at it in an hourly basis, in a 24-hour, 72-hour, or a 7-day rolling basis. So this is what we came across in the literature. And then the other dominant pricing model would be price models that based on the levelized cost of heating. And in the case of levelized cost of heating, the investment costs, the operation, maintenance, and fixed costs are all considered over the lifetime of any technology, any heating technology that provides heat. And in that, the studies show that when you set prices based on levelized cost of heating, you also then can include a flow demand component and a load demand component in your pricing model. And then if you look at it from an hourly resolution, it matches the dynamic cost of actually producing the heat much better. So these are the 2 dominant price models that have been found in literature up to now, which also basically argue the pros and cons of using it to capture flexibility. And now some findings about price models and business models. One theme that has emerged is basically using a marginal cost-based price model and coupling it with heat as a service. Now, in this case, what happens is the district energy company uses the customer-side flexibility enabling technologies, such as, for example, storage or heat pumps, and they use it to optimize the cost for either the district energy company side or even for a system-wide cost optimization. And they provide a set level of indoor space or water heating for a marginal cost-based pricing. So this is a pricing model and a business model that is emerging currently, where the district energy company has the steering or the operational availability of flexibility enabling technologies on the customer side. And another business model and price model that is emerging is basically levelized cost of heat-based price model with motivational tariffs. Here, when I say motivational tariffs, it means that sometimes there are negative prices for return temperature levels or for flow demand, especially when you couple it with seasonal or time of use. So motivational tariffs are looked upon as incentivizing higher energy efficiency and a reduction of demand, especially during certain hours or seasons. So these are two of the emerging sort of price models and business models that we are seeing, which are helping district energy companies capture and exploit flexibility. So let me now come to conclusions and further work. One conclusion that we find is that in the scientific field of district energy grid, capturing and exploiting flexibility through coherent price and business models is underexplored. It's an emerging field, so currently it's very underexplored. And also from our results, not all of the scientific work is connecting the business models to the price models. But exploiting flexibility in a coherent manner could be useful for the district energy company and also for the customer and for the entire system, especially given the cross-sectoral integrations with the electricity sector. So because of the ability of larger heating units such as CHPs to change from heat and electricity, and at the same time you have flexibility enabling technologies such as heat pumps using electricity. And then when you consider an integrated sector, integrating the sectors of district energy and electricity, this becomes even more interesting and useful. And then designing innovative, transparent, but at the same time fair business models for flexibility will become important and will need to happen. So this is basically how business models and price models are currently capturing flexibility in the district energy grid. And now I am happy to take questions if there are any, or I will hand it over to my colleague, Jan-Henrik.
There are no questions coming in, so please go ahead, Jan-Henrik.
Thank you, Anna. My name is Jan-Henrik Sällström. I work as a scientist at RISE, and I've been participated in Work Package 5. I'm going to talk about effects on maintenance and durability. I'll give a background, say something about damage and the model we have used, cost of maintenance, change of costs related to damage, and give some concluding remarks. Oops. Okay, sorry. To increase the usage of renewable energy and to optimize earnings of energy companies selling power and heat, the integrated system should be run with increased flexibility. This means that the heat network may be operated differently. In turn, this can lead to higher temperature peaks, more temperature cycles, higher average temperature, and in turn, this leads to damage and maintenance. Costs of maintenance and reduced durability are normally neglected in optimizations like this. A model for these costs are given here. A heat network consisting of pre-insulated pipes are considered here. Pre-insulated pipes consist of a steel service pipe, polyurethane insulation, and a casing of polyethylene. Damage to the steel service pipe can occur instantaneously due to high temperature peaks. And what can happen then is buckling or plastic deformation. Damage can also occur to the service pipe due to fatigue after many temperature cycles. Damage to the polyurethane insulation close to the service pipe can occur after long use at high operative temperatures. And this leads to deterioration of shear strength, and the failure mode is loss of adhesion between the service pipe and the polyurethane then. Here is the approach we have used. We have limited the temperature peaks so that we will get no additional damage and no additional cost for these. We need to count the number of temperature cycles for the networks before and after we change the operation. And then we need to estimate the additional damage due to fatigue of the service pipes. We need to count duration of the temperature levels for the networks before and after we change the operation. And then we need to estimate the additional damage due to the degradation of the polyurethane insulation. And then the actual key part of the model is that we assume that the maintenance costs are proportional to the increased damage occurring. We need to get an idea of how large are the maintenance costs. The maintenance costs in optimizations like this are treated quite poorly. We found two references where they mention maintenance costs in this context. And in one of the references, they estimated the size of the maintenance costs as 2% of the investment of the network. However, they were treated as constant costs then. To get a better idea how large the costs are for mature networks, we had a look into data from the Swedish Energy Market Inspectorate. And the maintenance costs vary quite a lot between energy companies. But they are about 1% of the reinvestment of the network, or about 3% of the sales of the heat. Now we get an idea of how large are the maintenance costs. Then we need to have some kind of estimate how large are the part related to fatigue of the service pipe and the degradation of the polyurethane. And there are no good data available on this actually, but we believe a reasonable value can be about 5% each of the total maintenance costs. The cost for the maintenance are related to the change of damage occurring. And to calculate the damage of the service pipe, the fatigue curve of the service pipes of the steel has been used. We have the stress range S and the number of cycles N that the pipe can endure at a certain stress range S. The damage of the polyurethane is based on that the reaction speed follows Arrhenius relation, given here. We have an activation energy found in the literature for the degradation of the polyurethane. And now I come to the concluding remarks, summing everything up. So we need to have the temperature history before and after we change to a more flexibly operated system. We need to count cycles of the temperatures, the temperature ranges. We need also to count duration of temperature levels. And we have to follow the boundary conditions. The temperature can't exceed certain levels. We need initial estimation of the maintenance costs. It can be real costs for the system. It can be fraction of the reinvestment or fraction of sales. And we also need to have fractions of the parts related to fatigue and to damage of the polyurethane. And if nothing else is available, let us take them as 5% of the total maintenance costs. The maintenance costs are divided into 3 parts, dealing with fatigue of service pipe, damage of the polyurethane, and everything else. And here the cost related to everything else remains constant, and the cost related to fatigue of the service pipe and the cost related to the damage of the polyurethane changes. The costs related to the fatigue of the service pipe are made proportional to the change of the damage occurring, and this can be calculated like this. And the costs related to the degradation of the polyurethane are related to the damage occurring of the polyurethane. And it is calculated like this. That concludes my presentation. Thank you. And I'm welcome to take any questions.
There are no questions in the chat, so Sarah might be the next presenter.
Yes, my name is Sarah. I also work at RISE as a researcher. Let's see if I have control over the presentation now. Yes, here I am. I'm based in Norrköping, and I've done this work together with Burcu, who works at IVL, but I will be presenting today. And I will talk about flexibility from the perspective of occupants of spaces that are heated with district heating. And we started a little bit with the question, what would increased flexibility mean for occupants? Well, it depends a bit on how it is achieved. I mean, it can be achieved, as also Suji was talking about, better sector coupling. We can have thermal energy storages in hot water tanks. These does not affect the occupants directly, but it can also be done through storing heat in buildings, and to do that also allow for greater temperature variations in the building. And allowing for greater temperature variation could have consequences for occupants, for the occupants of these spaces and for their thermal comfort. So in this part of the Flexi-Sync project, we asked ourselves, what impact could flexibility through increased variation in indoor temperature have on the thermal comfort of occupants? And what are the constraints for flexibility through increased variation in indoor temperature from the perspective of occupants? And to do that, we had this approach, and this is a bit of a simplification of what we did. But we started with a literature review, and what we wanted to get out of that was that we wanted to define important occupant-related aspects of how flexibility through variable indoor temperature is implemented, kind of the different ways that this way of having a more flexible district heating system can be implemented. I will talk more about this, and it will be clearer. Based on these aspects, we created 3 scenarios for how flexibility through variable indoor temperature could be implemented, and these scenarios included these aspects. And then we did a survey with the residents in which we asked them about what they thought about these scenarios. And the questionnaire was made with the residents in Sweden. The result of that was that we got answers to the research question, but we also got some interesting hypotheses for future work. So what are these important occupant-related aspects of flexibility? There are aspects directly linked to the variation in indoor temperature, aspects related to temperature and temperature span, aspects related to rate of change and duration of these different temperature levels, aspects related to time of the day and day of the week, like when do we have these variations, and aspects related to location, in which rooms they are present. And aspects related to seasons and unusual events, such as a really cold winter morning. But there are also aspects that are not directly linked to the variation in temperature. And these aspects are aspects related to information to occupants, which information that is provided to the occupants of these spaces, if any. Aspects related to incentives, if occupants participate, if the occupants that participate in a flexibility program is incentivized, for instance, through economical incentives or through providing a sense of contributing to a better future. There's also aspects related to voluntariness and control, if occupants can opt in or opt out of this flexibility program, and if occupants are given control of some of the aspects of flexibility. And aspects related to home adaptations and equipment, if the home if the home or the space is adapted in any way, for instance, through better insulation, or if smartness, for instance, is added. Let's see if I can switch. Yes, and based on this, we made 3 scenarios from the perspective of residents. And we made scenarios that we thought were, or we aimed for scenarios that were plausible, but not necessarily the most likely ones. to kind of not only stay on the safe side, but to experiment a bit more. And we made these scenarios adapted for Swedish preconditions, because there are some preconditions in Sweden that are a bit special to the rest of the Europe. For instance, heating is typically included in the rent. And we made them as stories from the perspective of residents. And we tried to make 3 distinctly different scenarios with different focuses. So one was focusing on comfort, one on environment, and one on your choice or you decide. And I will go through these scenarios really briefly with you. Scenario 1 we called small variations that does not affect comfort. In this scenario, we said that the maximum variation that we can have is plus minus 0.5 degrees all the time and everywhere. The residents have no control over this, and they are not given any information about it, and they are not giving any incentives. And this is the scenario that, based on a discussion with the housing companies that is also part of the Flexi-Sync project, this is the scenario that is most similar to the flexibility setup that will be demonstrated in the Flexi-Sync project. Then we also made a scenario that was a bit more extreme towards good for the environment, and we call it a little more variation that is extra good for the environment. And this is a scenario that is not really beneficial from the perspective of the residents, and we thought it was interesting to have that as well. And there we had plus minus 1 degree as the general variation. Sorry, I will just let someone in here. But also larger variation at night and cold days, and that people would get information about this, but also warnings when there would be extra cold days, and no incentives. And then we had a third scenario that we called you decide how much variation you think is okay. Here we had a lot of information and control options that you could control the variation as you would like, and have different variation in different rooms, etc. And also that you would get economical reward for a larger range than plus minus 0.5 degrees Celsius, but not really large, 20 to 50 euros per year. And it's worthy to note that this third scenario would demand a smart home. And then we did a survey with residents, an online questionnaire. And as I said, it was adapted for Swedish preconditions, and we also distributed it in Sweden. And in this questionnaire, we asked residents about their opinions about the current indoor heating, the variation in indoor temperature, and their opinions towards these 3 scenarios, and some other questions that I can go through in detail another time. And we had in total 88 respondents, which is not much. We had tenants from one of the project partners. We also had residents in a building cooperative, and we also had a Facebook ad. But it's we really must say that we had a very low response rate. So all of these results that I will be showing you needs to be interpreted with caution. But I will show you anyway. So kind of generally, the most preferred scenario was this third scenario where people get control over the variation. And I think it's interesting to note that in this sample, the scenario 2 that I said was not so beneficial from the perspective of the residents was still the second most preferred scenario, and then the third option was to have it as the way as they have it now. And scenario 1, where which is the one that we will be most similar to one that we will be testing in Flexi-Sync, was not really these respondents' favorite. And then we also asked people to kind of comment on these temperature ranges, what they thought about this. And we asked them if they would be positively affected, would not be affected, negatively affected. And as we can see, the plus minus 0.5 is much more accepted than plus minus 2, which is not surprising. But what is surprising is that even though we theoretically are not supposed to be influenced by a variation in plus minus 0.5 degrees, people are still thinking that they would be. Some people are still thinking that they would be. So that is important to know in the communication with residents, I think. In this sample, there's a breaking point, or something interesting happens around plus minus 1 degree Celsius. That's when people are kind of, the majority is still okay with this. And then with plus minus 1.5 degree, we can see that the people are less okay with this. And this also corroborates experimental findings in previous studies that with plus minus 1.5 degree, people start complaining more. And then we wanted to look a bit at what are the factors behind these opinions. And we saw that a really important factor is whether or not you're satisfied with your current heating. So we can see here on the left part here, you can see from what you think about your current heating from very bad to very good. And you can see that if you, for 0.5 degrees, it's not such a great difference between these. But if you look at plus minus 1 degree Celsius, you can see that if you have a very, very good or good current heating, you're more okay with variation. This is a very small sample, as I said, but it's not so surprising that you're more okay with variations if you think that your current heating is good or very good. And then if you go to 1.5, you can see that more and more people say that they would be negatively affected, and with plus minus 2 as well. What we also found was that satisfaction with current heating could also co-vary with which scenario that you preferred. So if you, for instance, think that your current heating is good or very good, we can see that you seem more accepting towards scenario 2, which is the one where, as we said, there's quite a large variation and you don't have control of this. And if it's bad or very bad or acceptable, scenario 3 looks really interesting to you, according to the respondents in this study. And if we look a bit more into what they thought about scenario 1 in relation to satisfaction with current heating, you can see that if you already have bad, people are negative about scenario 1 as well. And if scenario 2, we can see that if the heating is bad or very bad and also acceptable, people are a bit skeptical. And if you have a very bad or acceptable current heating, you are interested in getting more control over it, as you get in scenario 3. We also saw that age seemed to co-vary with which scenario you preferred. So we can see that the youngest age group, which in this case was 18 to 34, seems to be a bit more positive towards this scenario 2, which we think was a bit interesting. So what conclusions can we draw from this? Well, as I said, this was a limited, we had a very low response rate. It was a limited group of respondents. So I will first present the findings in literature that were corroborated by the survey findings. And one of these things that was found in previous studies, and that we also found, was that flexibility is really difficult to explain and to understand, but also that it's important to do so. So here I think we have a challenge ahead of us. And as I also talked about earlier, there's more than temperature range that is important for residents. For example, time of the day. What we also seen in previous studies and also in this survey was that residents have very specific and individual preferences in relation to heating. For example, they are accepting a very high variation during night, but maybe not in the morning. And as we've seen in previous studies and also in this, is that control over temperature and flexibility is very, very attractive to residents. And then we also have some tentative hypotheses based on these survey findings, but those really need to be confirmed or rejected in future studies. And what we can see there is that we had a lot of comments in the survey that residents want to be informed also about flexibility setups that theoretically do not affect their comfort, such as in scenario 1. In the questionnaire, we asked people to comment if they would like to change anything to scenario 1, and this was a comment that people made, that they would like to be informed, even though they are not theoretically not affected by this. Their thermal comfort is not affected by it. We also saw that some residents are willing to accept a deterioration of the heating service, as scenario 2 could be seen like, without any compensation. And as I said, especially younger residents show the highest acceptance of scenario 2. Of course, we don't know if this is related to age, because they are in this age span, or if it's a question of a generation. Is this a part of the Greta generation, for instance? And we can also, from this sample, we can also draw the hypothesis that it's how satisfied you are with the current heating seems to influence the extent to which you accept higher variation in indoor temperature. That was all I had in slides, but I think there's been at least one question that I didn't really manage to read.
Can you see the questions, Sarah, or should I read them for you?
Wait, I can.
There are 2 questions in the chat.
Yes, it's not all apartments have same indoor temperature and are affected differently with average variation. How do you ask the questions considering how apartment owners experience? How the apartment owners experience? Yes, we ask the apartment owners how satisfied they are with their current heating, as I showed you. But in the scenarios, we also said. We formulated it, imagine that you have the same average temperature as you have now, because we really wanted to focus on how they would be affected by the variation, not a change in set point temperature. Was that an answer to your question, Cecilia?
Yes, it was. Thank you, Sarah. It's only that some apartment has, they have lower temperature than the average. We say that they have 20 degrees, then have 19 degrees is not as comfortable as you can imagine. So yes. That's what we're thinking. Is that some have 24, some have 20. So when you reduce the indoor temperature 1 degree, then it's different from 23 to 19.
Yes. Yes, and it is also one of these aspects that is really, really important to kind of have in mind when you set up a flexibility program, to make sure that if you set a minimum limit, for instance, if we look in more details in the scenarios, we also specified that in scenario 2 we specified that you can never have it lower than 18 degrees.
Thank you.
But I can also share the kind of the scenarios are more detailed there are more detailed versions of it. This was really a short version of them. Yes. And a question here, if it would be possible to share the occupant survey. Yes, get in contact with me. I will write my email here so we can kind of discuss what part you wanted. And then could you explain the reason why there's no incentive in scenario 1? Yes, this was kind of based on the fact that that was how we imagine that it will be in the Flexi-Sync demonstrations in Sweden. Because in Sweden, as I said, normally participants or residents do not pay for heating separately, but they pay it as a part of the rent, and it's the same. It's not affected by how you use your heating in your apartment, but it's a kind of it's included in the rent, so it doesn't matter really what you do. So and that was really based on the fact that that is how the housing company is planning to do it in the Flexi-Sync demonstration. So we wanted one scenario that was most similar to that. And the other, in scenario 2, we chose to not have incentives because we wanted to have a scenario that was really, really kind of good for the environment, but maybe not so good for residents, to see like how would people react to this? Are there anyone who would be accepting towards this? Because I've seen in previous studies that sometimes some people are willing to do more than we sometimes expect for the sake of the environment. So I thought it was interesting to do that. Yes, but where will the benefit of flexibility be distributed? To the housing companies. I guess I'm not sure about this. Suji is better. It depends on the price and business model, I guess.
Yeah. So in the case of this Flexi-Sync project, the customer and the end user are not the same. So the customer is the housing company, whereas the end user is the resident. And ideally, you would want a business model to distribute or redistribute the benefits to both the customer and the end user. But this is also something that we will in the future look at. Does it answer the question? I don't know. Looks like there aren't any. Then I shall move on. These are the references you had. You all can follow the project through the website, and also you all can sign up for the newsletters, webinars, and social media. We use the hashtag Flexi-Sync without the hyphen. And let me take this opportunity to thank everybody who participated.
Yes, and if you have any further questions, please get in touch with me. And also you who wanted to get more details from the get the survey in detail.
Thank you, and likewise the same with me as well.